Logarithmic equations can be solved one of two ways. One way is similar to the way we approach some exponential functions, where if we can make it a log, so of something equals the log of something, as long as the bases of the logs on both sides are the same, then we can just set the insides equal to each other, and so we can use the expression we're dropping the logs. The other circumstance, which we'll come across in the second example, is where we cannot just set logs equal to logs because we have a mix of logs and regular numbers. So in that case, in order to solve, we're going to have to use our technique of rewriting logs as exponentials. But if we clear the screen here, for this first one here, it's a logs bonanza. We have natural log of 2x plus the natural log of x minus 3 equals the natural log of 8. And so in order to solve, we're going to combine the two logarithms on the left so that we'll have a single logarithmic expression on the left equal to the logarithmic expression on the right. And so then we can go ahead and set the insides equal to each other and solve. So the way we can combine these logs is using our log properties. So when we have two logs that are being added together, we can rewrite it where it's the product of the two insides. So it's going to be the natural log of 2x times x minus 3. So we're going to combine those two into a single logarithm, and then that equals the natural log of 8 on the other side. And so now that we have it down to a single logarithmic expression on the left and one on the right, we can set those insides equal to each other. So we've got 2x times x minus 3 equals 8. And so now I need to go about solving this using our ordinary equation solving techniques. So I'm going to distribute here first. So we're going to get 2x squared minus 6x. And then I'm going to move the 8 over to that side because I'm ending up with a quadratic equation. Before trying to factor this, I can see everything's divisible by 2. So I'm going to go ahead and do that. So I get x squared minus 3x minus 4 equals 0. And so now I can factor and solve for x. So we break it up into our two sets of parentheses. We know it's x is the first piece. We're multiplying to make a negative 4, so it's got to be one of each, a positive and a negative. And then hopefully it's pretty obvious that it's got to be minus 4 and plus 1 for us to end up with that negative 3x in the middle. So then we take each of these factors and set them equal to 0. And so then out of that, we're going to get two answers. If I subtract 1 from both sides, I'm going to get x equals negative 1. And then if I add 4 to both sides, I'm going to get x equals 4. Now the one thing we do have to be cautious of is we have to go back and check to see that neither of these answers results in the log of 0 or the log of a negative number. And indeed, if we try to plug negative 1 in for x into both of these expressions on the left, we're going to end up with a negative inside of a logarithm, which is a no-no. So therefore we have to throw out negative 1 as one of our answers. It's extraneous. 4, however, is just fine. If I plug in 4 everywhere, I'm going to get positive values inside of my logarithms, and it's going to work. So x equals 4 is our only answer to this equation. In our second example, we can't use the same techniques of getting all logs on one side and all logs on the other side because not everything in the expression is a logarithm. So we're going to have to eventually rewrite this as an exponential. But in order to do that, we need to combine these two logarithms into a single logarithm. So we're going to do that the same way that we did on the previous example, where I've got the sum of two logs that have the same base. So I can rewrite that as a single logarithm base 2, and then I just need to multiply the two inside. So x plus 1 times x minus 1, and then that still equals 3 on the other side. And so now I can clean up this inside here first if I want. I can go ahead and FOIL that out, difference of squares pattern. So we're going to end up with x squared minus 1, and we still have the equals 3 on the other side. Now at this point we're ready to go ahead and rewrite this as an exponential. That's the only way we're going to get the x out from inside of the logarithm. So just like as we have an exponent in, or a variable in an exponent, we need logs to solve. So here a variable is inside of a logarithm, we need exponentials to solve. So if I rewrite it, 2 is the base of my logarithm, 2 is going to be the base of my exponential, A logarithm is an exponent, so it's 2 to the third equals the input of the logarithm becomes the output of my exponential, so x squared minus 1. So 2 to the third we know is 8 equals x squared minus 1. Now I can solve by factoring, by subtracting 8 from both sides, or I can solve using square roots, since there's no x term, by adding 1 to both sides. So I end up with x squared equals 9. I take the square root of both sides, and I get x equals plus or minus 3. And once again, just like on the previous question, I need to go back and make sure that those answers both work. And very quickly we see that that negative 3 answer is not going to be good, because it's going to result in a negative inside of each of those logarithmic expressions. So I have to throw the negative 3 out, and so my only answer on this one is going to be x equals 3.